I finished the entire TCM Security Linux course today. Day 2. Not day 30, not day 10, day 2. Yesterday I started Linux from zero. Today I finished it completely. That is not normal. That is what 12 hours a day looks like. That is day 2 of 365 and it was bigger than day 1. If you are new here, 25 seconds of context. I am a JEE Dropout from Kota. I am building a physics simulation engine for ISRO and DRDO from absolute zero in 365 days, targeting incubation at IISc Bangalore. 12 hours of study every day. Everything's documented publicly. Day 1 is linked below. This is day 2. Let us get into what happened. Let me start with the biggest thing. I completed the entire TCM Security Linux fundamental course today, start to finish in 2 days of this journey. Linux done. Here is what the full course covered and why it matters for building our defense physics engine. Linux file system and navigation, everything in Linux is a file. The OS, the devices, the processes, configurations, all organized in a single tree from the root directory. I can now navigate any Linux system without any hesitation. My physics engine will eventually run on Linux research servers. I need this foundation now. I have it permissions, users and file security, chmod, sudo, who can read, write or execute files. This matters when running simulation code on secure defense research machines where access control is strict. Processes and basic shell scripting, running programs, managing background processes, writing bash scripts. I wrote my first bash script today. It automatically creates a dated folder and save my study notes inside it. Simple, but I wrote it. It works. Linux is now a tool I use, not as a subject I studied. That shift happened today. Second, Harvard Python course. First course, today's functions and variables. Let me explain each one and exactly why it matters for what I am building functions. A functions is a named block of code that does one specific job. You define it once, you call it 1,000 times without rewriting it. In my physics engine, calculate distance, apply gravity, detect collision, apply forces. Each of these will be a function written once, called millions of times per second during simulation. Without functions, a physics engine is impossible to write or maintain. Variables store the state of everything. Position is a variable, velocity is a variable, mass is a variable, rotation is a variable. Every object in my simulation, every particle, every rigid body, every projectile will have dozens of variables describing its exact state at every single frame. Functions and variables are not Python syntax, they are physics engine architecture written in Python. Yes, I know this sounds extremely basic, but here is what I have understood about learning. You cannot skip the foundation. The engine I am building will eventually have thousands of lines of C++ code. Every single one of those lines start here at lecture 1. The difference is I am not learning Python for a test. I am learning it to build physics simulation quickly. That gives every concept a purpose, and purpose makes learning faster. Third pillar of today, mathematics, continuing to build the foundations, algebra and logarithms. And I want to tell you something about logarithms specifically. I studied logarithms in coaching. I passed the exam. I forget everything within 2 weeks because I had no idea why logarithms existed. Today I know why. Logarithms compress exponential skills. They turn multiplication into addition. In physics simulations, when you are dealing with numbers that range from sub-millimeter particle scales to kilometer range, trajectory, distances, logarithms are how you manage that range without your computer losing its mind. Why? The how becomes 10 times easier to remember. What did I struggle with today? I am going to tell you exactly. Linux file paths, absolute paths versus relative paths. I spent almost 45 minutes completely confused about why the same command worked in one folder and not another. The fix, I drew the file system as a tree diagram on paper, physically mapped where I wanted to go and what the path looked like from both perspectives. The moment I drew it, it clicked. The lesson: when something confuses you in code or in math, stop typing, pick up a pen, draw it. The physical act of drawing makes abstract concepts concrete. I will be using this lesson every day for the next 363 days. Let me show you exactly where day 2 sits in the 365-day roadmap. Linux complete. I can now work on any machine that will run my engine, research servers, embedded system, defense computing environments. I will not be blocked by the operating system. Functions and variables, it sounds basic. But when I learn loops, conditionals, these three concepts alone are sufficient to write a basic 2D particle simulator in Python. That is my target for week 3. A real simulation gravity, drag objects moving on a screen according to real physics equations. The maths, logarithms, these are the tools I will use in phase 3 to derive physics equations from scratch rather than copying them from a textbook. Day 2 is done, Linux complete, Python for Harvard first lecture complete, mathematics basic logarithm. Tomorrow day 3 I go deeper into mathematics, complete the second and third lecture of Harvard course. I have been waiting to get to this. I also write my first Python script that does something real, not just hello world. Something that actually calculates a physical value. Subscribe if you want to follow this every day. 363 days remaining. See you tomorrow. Jai Hind.